Hi everyone, welcome to MCK Hub. Today in our video we are going to cover merge sort algorithm, which is part of data structure and algorithms videos. So what is a merge sort? So merge sort is a sorting algorithm which follows divide and conquer approach. So we will see in detail like what is that. So we are going to divide the list into two equal halves. So going to sort each half and then merge those sorted out so that finally we'll be getting the sorted list. So what is its algorithm? So divide the array into two sub-arrays and continue to divide those sub-arrays as long as current array has more than one element. So till we reach atomic level of element, so we are going to continuously divide that sub-array. So finally we are going to merge two subarrays by putting the lowest element first. So we'll be keep on doing that until there are no subarrays. Yeah. So what is merge sort algorithm? So this is a simple representation like we have merge sort method with input parameters or array start and the end position indexes we are passing. So if start is less than 8, then we are calculating the mid of the given array like with start plus end by /2, so that we'll get the midpoint of the array. So we are going to recursively calling that same function with till from array comma start comma mid. Okay, so from starting position to midpoint, so we are recursively calling the same function so that we will reach the atomic level of element. And similarly, we are going to call the same function recursively from midpoint to the end of the array. So like this, we are going to call it recursively. So till we reaches the individual level of array. And then finally we are going to call merge method merge function, so which inputs are array start mid and the end indexes. Okay, so here we are going to merge, like we are going to sort the subarrays and then now we are going to merge it in a certain order, and then we are finally calling this end merge method. So we'll see with one working example. So I have taken one array with 8 elements which has 13, 28, 26, 8, 31, 16, 38 and 42. So what I'm going to do, so first I'm going to divide this given array into two equal halves. Okay, so based on this array size. Okay, so my array size is 8 so that I can divide my array into two equal halves with 4 elements each. So 13, 28, 26, 8 and 31, 16, 38, 42. So again we are going to divide these two subarrays into uh, new arrays of size again half. So now we have arrays of size 4 each. So I'm going to divide into two halves like with two elements. So 13 and 28, 26 and 8, 31, 16, 38, 42. So now again I'm going to divide these two subarrays, okay, again into atomic value. Okay, so that means we cannot divide it further. Okay, so 13, 28, 26, 8, 31, 16, 38, 42. So like that now I got the atomic value of each element. So now we need to combine them in the same way like how we broke it. So first we'll be comparing 13 and 28. So already these are in sorted order. Like so we are expecting these elements should be in a ascending order. So lowest element should be first and highest element should be last. So 13 and 28. So 13 is less than 28. So no need of sorting. So again just try to compare the next two elements. Okay, 26 and 8. So we need to sort them, like we're going to place 8 as, so basically we need to swap these elements. Okay, so 8 will come first and 26, and then compare 31 and 16. Again 31 is greater than 16, so again we need to sort it, like we need to put 16 first and then 31. So again 38 and 42, so it's already in sorted order, so no need to do anything. And now uh, once we get this position, now we are going to merge it. Okay, so 13 and 28 we are going to make it as one set. So 8 and 26 another set, and similarly 16 and 31 another set, and 38 42 another set. So in the next iteration, what we are going to do, we are going to compare arrays with two data values and merge into array of found values in sorted order. So now I'm going to compare 13, 28, 8 and 26. So I'm going to do the comparison 13 and 8. So here these are not in sorted order. So just try to swap the values. Okay, 8 and 13. So similarly again we are going to compare 28 and 26. So again these are not in sorted order, so we are going to switch it 26 and 28. Okay, so we are going to get, again now we need to sort these elements. Okay, so finally we are going to get the list. So finally from two different sub arrays, so we need to make it combined, and then we need to get the sorted order. So like 18, 13, 26 and 28. And similarly, so in this other array, again we need to put the other half in the sorted order. So first you will get 16, second 31, 38 and 42. So in the next iteration, like we are going to compare arrays with four data values, and we need to merge them into an array of found values with in a sorted order. So now we are going to do the comparison with these two subarrays of this which are already sorted, and then we are going to get the final result as like this: 18, 8, 13, 16, 26, 28, 31, 38, 42. So next, so when it comes to time complexity, so the best case is order of n into log n. So average case and worst case is also the same thing. So best case is like no sorting is required, that is given array is already sorted. So even that case also algorithm will take this much of time, n into log n. Average case, like when the array elements are in jumbled order, so that is not properly ascending or not properly descending, even in that case also it will take the same time. And worst case, when the required array elements are required to be sorted in the reverse order. So already they are given in descending order. So if I want to put those elements in ascending order, then in the worst case it's the same time complexity. So space complexity is order of n. So we need one extra variable for swapping the elements. So now we'll see with the programming. So this is the sample program for this match sort. So which I have taken array of like 13, 35, 22, 5, 30, 15, 48 and 37. And then I am calculating the length. So I am creating an object for my class, match sort demo. So I created an object, and then I'm just added one print statement. So before sorting, what are the elements, and I'm just printing array. So whatever the elements present in the array, so I'm just printing those elements using this method. So it is just a for loop, print array, iterating the for loop and just fetching the array element. And similarly, now I am calling this merge sort. So merge sort method, just in input parameters I am passing array in integer array, and then int array, and then this is the start position, so that is 0, and then length of the array like n minus 1. And then after printing, so after sorting, so I'm just again printing the what are the elements. So I'm calling the same method, print array. Yeah. So if we take the merge sort, so I created one method. So I'm just checking whether this beginning is less than end element or not. And then if that is the case, I'm calculating this mid position so that to break the array into two halves. Okay. So, and then, so I just calculated the midpoint, and then recursively call the same merge sort method. Okay. So array BG, it's like begin position and mid position. So till it reaches individual level, so it is going to call recursively. And again, I'm calling this same method. Okay, so with the array mid plus 1 and the endpoint. So this is also going to recursively call the other half till it reaches the individual level of element. And then finally, I'm calling this merge method, like to arrange the elements in the sorted order. Okay, so this is my merge method. First parameter is int array, and second parameter is beginning, and this third parameter is mid, and fourth parameter is end. So I just declared three variables I, j, k, and calculating the n1. So mid minus beginning plus 1, and similarly n2 for n minus mid and n minus mid. So here I am creating two temporary arrays. So left array and right array. So just to get the calculated elements. Okay. So left array with size of this one, mid minus beginning plus 1, and right array with size of this one, n2 equal to n minus mid. So for copying data into temp arrays, so I'm just iterating the loop, like left array, and then just getting the elements from the array, like beginning plus I. So 0th position plus I. I'm just iterating it so that I'm copying the data into the temporary arrays. So first for left array, and then second for right array. And then I'm just initializing with initial index of first subarray and second subarray, and then also for the merged subarray. So I'm just iterating with for loop. So with this I less than n1. So n1, as we know, the length of the left array, and n2 is like length of the right array. Okay. So I'm just checking this condition while I is less than n1 and j is less than n2. I'm just checking whether this left array element is less than or equal to right array element or not. If left array element is less than, then I am just arranging that merged subarray like with array of k equal to left array of I, and similarly just iterating. Otherwise, if it is not, then array of k equal to right array element, and then iterating this j plus j. So if else, and then I am iterating this k, and then finally I'm just iterating while loops with individual left array ones and right array ones. So like this, I'm just copying the elements into the final array. So now if we run it, so we can see before sorting these are the elements 13, 35, 22, 5, 30, 15, 48 and 37. So after sorting we can see elements are in ascending order. So lowest element is the first and highest element is in the last. So if you want to see like how these elements are getting modified in every iteration, so just added one print array in the merge so that we can see what is happening for the array after iterations. Yeah, we can see first 13, 35, 22, 5. Okay, so first it got splitted into two and then it got rearranged. Okay, so 13, 35, 22, 5. So it's getting compared and the other half it remains same. So after this sometime like we can see 5, 13, 22 and 35. So the first half is got sorted. Okay, and then next half we can see 30, 15, 48, 37. So the lowest of these other half, so it got sorted 15, 30, 48, 37. So again in this step we can see 15, 30, 48, 37. So again these two got sorted and swapped. Okay. So finally we have halves with 5, 13, 22, 35 and 15, 30, 37, 48 as the two sorted two halves. Okay, now in the last iteration like these two has to be rearranged and then input it in the sorted order. So 5, 13, you can say 15 and then 22, 30, 35, 37, 48. So like this merge sort works. Thank you guys.